Alright, so here we have our AP Calculus AB Unit 3 pretest, analyzing derivatives. There it is. This is going to be kind of an in-depth video since I don't have a class in front of me, so this is meant for Geo and Sego and all the future years who will use this video and put it to good use. Alright, so for what values of x is the function decreasing? So the key things that I'm looking at here are function decreasing. In fact, I don't even care about function. I just care about decreasing. What is the definition of f decreasing? So let's write this off to the side. F decreasing. The definition of f decreasing is where f prime is less than 0. And if you ever don't know the definitions that I'm quizzing you guys on throughout the video, do the speed sheet for this unit. It will help you so much. In fact, just do the speed sheet for all of the units and it will really help you since this is part review for this unit. So if the definition is where f prime is less than 0, I need to find f prime. So here we go, f prime of x. When I take the derivative of a constant is 0, it goes away. The derivative of 15x is 15x, and again, if you're ever questioning, or sorry, it's 15. If you're ever questioning why it's 15, because it was 15x to the power of 1, but the 1 multiplies down here, so 1 times 15 is 15, and then this goes to the power of 0. You subtract 1, and then it goes away. So I just have 15 plus 12x. Why 12x? 2 comes down. 2 times 6 is 12. It goes down a power from 2 to 1, so this is x to the power of 1, minus 3x squared. All right, so I have the derivative, the first derivative, and now I need to factor this thing and set it equal to 0. So factoring it is the hard part, and it's where most people start making their mistakes. So if I rewrite this, I'm going to use a different color here because I'm rewriting this. This is negative 3x squared plus 12x plus 15. Notice that my leading coefficient here is negative, and whenever we factor polynomials, having a negative leading coefficient makes it really, really difficult. So I'm going to turn that to a positive and factor out the greatest common factor at the same time. The way that I do that is I factor out a negative 3. So if we need to review factoring for AP Calculus, just let me know and we can do that. So minus 3 or negative 3x squared divided by negative 3 is just normal x squared. We have minus 4x and then minus 5. Again, I'm just dividing 12x divided by negative 3. Positive divided by negative is a negative. Hopefully all of that is okay. Okay, I'm going to factor this even further. So now this problem right here is going to be a ninja star problem, or you can just kind of factor this in your head. What times what is negative 5? Well, 1 and 5, or 1 and negative 5, or negative 1 and 5. If the middle term is negative, the bigger number 5 has to be negative, so it's going to be x minus 5 times x plus 1. And I forgot here that my negative 3 was my greatest common factor. Let me put that out to the left-hand side here. You can't just get rid of that negative 3 also. I think that's probably another big error that people make on number 1. They're like, oh, well, I'm going to be setting this thing to 0, so get rid of that negative 3. And you're correct. That will not give you a critical value, but you still need to leave this in factored form because when I plug in numbers back in, when I'm doing my number line down here, it does matter that this is a negative because you're going to be doing negative times whatever, positive or negative, and this is always going to be a negative. So let's go ahead and find our CVs finally. So CVs, it's where the numerator, the top or bottom is set equal to 0, where f prime is equal to 0 or does not exist. And I don't have a bottom, so I'm just setting each of these to 0. This will give me a CV of x is equal to 5, and this will give me a CV that x is equal to negative 1. So I have my CVs. I guess I can move this over here to make that make more sense. My CVs are x are 5 and negative 1. Now I need to graph these on my number line. So let's make a quick little number line. It doesn't need to be too formal here. This is my number line for x, and let's label our CVs. We have a CV over here at negative 1 and here at 5. And you might notice I've already talked a lot of time about this problem. You're only supposed to have about 2 minutes, but hopefully you don't have to explain this to me. You can kind of skip steps here. These are both CVs. We'll label them. That's a CV, that's a CV, and I'm looking for decreasing. I'm going to choose the easiest possible number for a test point. I'm going to choose 0. When I plug in 0, I'm plugging into my factored form that has a negative 3 with a GCF out front. So when I'm plugging in, I get a negative. I get 0 minus 5 is a negative, and 0 plus 1 is a positive. Multiply a negative times a negative, and you get a positive. So that means that this is a positive interval, which means that this is f increasing. Since we know that that is increasing and both this power here is 1, this power here is 1, they are odd powers, so the critical values corresponding to these values should be flipping over that CV. So if it was a positive, the sign should be flipping to a negative. So I have a negative and a negative over here, which means that it is decreasing from less than -1 and greater than 5. This is F decreasing. This is F decreasing. And again, if you don't like the method of using odds up here, you can always plug in. And you can say, okay, well, I'm going to plug in 6. 6 will make this a negative, a positive, and a positive. That will all be a negative. Yeah, so the correct answer here is less than -1 and greater than 5, less than -1, greater than 5. Correct answer is D. All right, on to number 2. So how many extrema does that function have? We already have the f prime, which is going to make it easy. What is the definition of extrema? So f relative extrema. That's where f prime has a sign change. And since we're dealing with f prime, it gave us f prime. There's less work for us to do. So notice that we have an odd power here and an even power. Whenever I have an even power, it's impossible for me to be negative. It's impossible for me to change signs at all. So this one is always going to be positive. This term over here can be negative. So when we find our CV and set this equal to 0, this is the only one that's going to have a sign change. So your general rule of thumb, your hint for these is look for odd powers. Look for odd powers. Anything that has an odd power, that is going to be relative extrema. How many do we have? Just 1. So the correct answer here is B, 1. Number 3. What are all values of x where this is increasing? All right, so again, underline the word increasing. You should be doing this when you're taking the pretest or the test. You underline your key vocab that's going to make you define something. So what is the definition of f increasing? F increasing, that's where f prime is greater than 0. So I need to find f prime. I don't have it yet. So the problem with this one is that I see an x here and an x here. I have two x's. They're being multiplied by each other. I'm using product rule. And I have E house. I have power house. All right, so let's do product rule. Product rule. What is the definition of product rule? You should know this. It's 1d2 plus 2d1. All right, so 1, I'm going to consider this term, and then 2 is this term. So if I'm saying 1, it's going to be x squared minus 3. That's going to be times d2, the derivative of 2, the derivative of e house. Well, the derivative of e house is just e house, so e to the negative x. That's the doubter. But now we have to do dinner. So here's our inner. If I take the derivative of negative x, I just get -1. So dinner is -1, so times -1. So we had doubter and dinner. All right, that is all d2, and now we need to add 2. 2 is e to the negative x, e to the negative x, and derivative of 1, the derivative of x squared minus 3 is just times 2x to the power of 1, or just times 2x. All right, so now we need to figure out how to factor this thing and set it equal to 0, because that's essentially what we're doing. We're trying to find where it's greater than 0, so set it equal to 0 after we factor some things out. So after I factor this thing, I guess I can multiply it all together first of all. So I'm running out of room here, so I'm going to have, this is negative e to the negative x because it's -1 times e, so it's really just negative e to the negative x. And I'm left with, we'll say, negative e to the negative x, x squared minus 3 e to the negative x, plus 3 e to the negative x, because this is a negative term times a negative, which is a positive here. And then I'm going to add 2e to the negative x, x. That's all of this term right here. All right, so I have 3 terms, 1, 2, 3. What is the greatest common factor of all of them? Let's factor it out. I see an e to the negative x in all of these, and that's the greatest common factor. So let's factor that out. It's going to be e to the negative x times, now I'm left over with a negative and an x squared here, negative x squared. I'm left over with a 3 here, so positive 3. I'm left over with a 2 and an x here, so plus 2x. And from here, I'm going to go ahead and set this equal to 0. So I'm now saying e to the negative x times this negative x. So I was going to leave it like this form, but I don't like having my first term, my leading coefficient, be a negative here. So I'm going to factor out another negative as well. Just a rule of thumb, it's easier to factor things when your leading coefficient is not negative. So if I factor out a negative, this is going to be positive, then negative, then negative. And I'm also going to put the 2x second because it's writing it in standard form. So I'm going to be left with x squared minus 2x minus 3. And I'm going to set that thing equal to 0. Am I going to set it equal to 0? Maybe I should still be factoring this thing. I know it's a lot of work to factor this thing. So I'm going to keep this, I'm going to change this to black because I'm still factoring this thing. I can now factor this thing because this is going to be equal to negative e to the negative x times, and then you're kind of ninja starting this in your head. What multiplies to negative 3? 3 and 1. So negative 3 and positive 1. X minus 3 and x plus 1. Okay, now I can set this equal to 0, and I've basically done all the hard work. So if I say 0 is now equal to negative e to the negative x times x minus 3 times x plus 1, my critical values happen. This will never be 0, by the way. This is always just a negative. It can never get to 0. It's one of the properties of an exponential. This can give us 0. We can say that x will be equal to 3 and x will be equal to negative 1. Notice also that both of these are 2 odd powers, which means I am going to have relative extremum at those critical values. So I'm running out of room, but I'm going to do my number line up here at the top. So when I make my number line, here's negative 1, that's a critical value, and here's 3, that's also a critical value. Let's choose the nicest possible number, 0. When I plug in 0 into my factored form, this is my fully factored form, this is always going to be negative. It's always going to be negative because that's always some positive number and then multiplied by negative. So always going to be some negative number, and then this is going to be 0 minus 3, which is negative. Can't really see that, negative. And then 0 plus 1 is positive. What is a negative times a negative times a positive? That is a positive, which means this is an increasing right here. And we know that it's going to switch signs over these critical values. So that means it's negative over here, which means it's decreasing and decreasing. And we were asked where it's increasing. So between negative 1 and 3. Between negative 1 and 3. Lots and lots of work to get to answer D, but there it is. Number 4. We have some function, and it's defined on 0 and 9, so it can't go outside of those bounds. What is the relative minimum? So let's define that. What is an f minimum? A minimum is where the first derivative, f prime, switches from a negative to a positive value, which means I need to find f prime. If the definition deals with f prime, that's why it's so important to have these definitions down. You know, whether you're looking for the first derivative, second derivative, etc. So here's f of x. Let's say f prime of x is going to equal, 3 is going to multiply down, and I'm going to get 3 over 3, which is just 1. So I'm just left with nothing x to the power of, and it goes down from 3 to 2, minus, okay, 2 times 4 is 8. X, it was 2, so it's now a 1, I'll just leave it as an x, plus 12, and minus 5, that goes to constant, so get rid of that, don't think about it. There's our first derivative. So again, we're going to try to factor this thing a little bit more, set it equal to 0, and then find critical values. So factoring this thing, I have x, what times what is 12? 3 and 4, that doesn't help us. 6 and 2, there we go. X minus 6, x minus 2. X minus 6 and x minus 2. Okay, perfect. Now that we've factored this thing, let's go ahead and find critical values by setting this equal to 0. So x minus 6 should be multiplied by x minus 2, and all that is set equal to 0. Again, you're setting the top and bottom equal to 0 to find critical values. We don't have a denominator set equal to 0, so we just set the top equal to 0. From that, we get the CVs are at, I have room over here, so I'll say x equals 6 and at x equals 2. Those are our CVs. CVs. So let's go ahead and make our number line over here. We can say that we have 2 right here, 6 right here. Ooh, that's a bad 6. 6 right here. Those are our critical values. Critical values. So let's choose the easiest possible number to plug in. I like 0. 0 is really easy. Maybe you like 1. I like 0. 0 minus 6 is a negative, and then 0 minus 2 is a negative. A negative times a negative is a positive. Is it going to switch over when I pass over the critical value? Yes, because both of these are odd powers. So I'm going to switch signs to a negative and then switch signs again to a positive. From there, I know that this is going to, I don't even need to write increasing or decreasing because it's only asking me what the relative minimum is. This is the definition. Where do I change from a negative to a positive? And it's kind of hard to see right there. Let me make the positive slightly bigger like that. And you're going from left to right. You don't go from right to left. So from left to right goes from positive to a negative. No, from a negative to a positive. Ah, right there. There is our minimum. So this is our minimum at 6. So the x value is 6. Correct answer is D. Number 5. We're looking for a relative maximum. Okay, define it. What is an f maximum? A function maximum is where I have f prime that changes from a positive to a negative. So again, I need to find f prime. I don't have it, so let's find it. F prime of x, the first derivative with respect to x, is 5 multiplies by 3, 15. X, it was a 5, minus 1, it turns into a 4. Minus 3 multiplies by 5, it's 15 again. X to the power of it was 3, or subtract 1 and you get 2. And a constant derivative, constant is always 0. Don't worry about it. All right, so from here, we need to now factor and then set this thing equal to 0. So when I factor this thing, I can pull out a 15, obviously, for the coefficient. And I can pull out an x squared, because there's an x squared in both of these. So 15x squared. And when I pull that out, I'm left with x squared minus 1. And you should know that this is a difference of squares because x squared is a square, 1 is a square. So this is now equal to 15x squared times x plus 1 times x minus 1. Whenever you have a difference of squares, it's a conjugate pair when you factor it. All right, so we factored this whole equation. I can just copy and paste this. Copy and paste this in a different color. So I'm going to set this thing now equal to 0. When I do that, I'm going to be using the zero product property 3 different times. Each 3 of these terms is set equal to 0. So when I do that, I get x is equal to 0 here, I get x is equal to -1, and x is equal to +1. So we have 3 different critical values. And notice that these are both odd, and this is an even, which means it's not going to switch signs over x equals 0 for that critical value, but it is going to switch signs over x equals -1 and x equals 1 for those critical values. Let's go ahead and make our x-axis. So here's our x-axis. I can move that down a little bit because I need to write on top of it as well. So I'm graphing all of our critical values. I have -1, I have 0, and I have 1. Let's label those. So those are our critical values, critical values, critical values. And let's do a test point. No, it's not really a good test point. I'm going to just choose 2. I like whole numbers, and I like positive numbers. So if I plug in 2, then this is always going to be positive because it's something squared. So it's going to be positive here. When I plug in 2 here, it's going to be 3. 2 minus 1 is 1, which is positive. 3 positive multiplied together gives us a positive. And then we know it's going to switch over x equals 1 because that corresponds to an odd power. So it's going to be negative here. Negative there. Come on, circle it. There it is. I'm not going to switch over x equals 0 because this is an even power that corresponds to that critical value. So it's going to be negative yet again. And then when I jump over the critical value -1 corresponds to this, and it is odd. Therefore, it's going to switch to a positive. All right, so we're looking for a maximum. Where do I go from a positive to a negative? Well, I go from a positive to a negative at this critical value and nowhere else, just at -1. The correct answer is A. And I can label it in our graph as well. That is a max, and this is a min. All right, we're on to number 6. We finally have a rational function, a fraction. Kind of. We could probably turn this into a non-fraction because we don't have a variable on the top. Okay, so it's looking for where it's concave down. So what is the definition of f concave down? F concave down. The function is concave down where the second derivative is less than 0. So we need to find not only the first derivative, but the second derivative as well. So in calculus, we don't like fractions because it means quotient rule, which is kind of gross and ugly. So let's not use quotient rule. You don't have to since there's no variable in the top. Let's go ahead and rewrite this thing as y equals I still have that negative 5, but this x minus 2, since we moved this x minus 2 to the numerator up here, we can make this a negative 1 power, and now it's in the numerator. You're allowed to do that. Rules of negative powers. So now we have that, we can take y prime. Y prime, when I take the derivative, this is powerhouse now because it's a power. I still have this coefficient in front. That's always going to be there. Coefficients always stay there when in any house, essentially. So I still have the negative 5, but I'm going to multiply down by negative 1, so negative 5 times negative 1 is a positive 5, and then rewrite the inner x minus 2. It was a negative 1. I'm going to subtract a power, and it is now negative 2. All right, now I have to take the derivative of the inner. The derivative of the inner is just 1. So we didn't really have to even worry about dinner in that case. So once we found the first derivative, now we need to find the second derivative because the definition of the concave down is where the second derivative is less than 0. So here we go. Y double prime. And notice that I'm not switching this back to a fraction because we're going to have to take the derivative again. I don't want to have to switch it back to a negative power. Just leave it. So now the negative 2 is going to come down and multiply by the 5 to get negative 10. The inner is still the same, x minus 2, and it's no longer to the power of negative 2. I'm going to subtract 1 and I get negative 3. All right, so I have everything. I can actually rewrite this one now that I have my second derivative. I can write that as negative 10 on the top. It's kind of undoing what we just did to get to this step. I have negative 10 on the top, and on the bottom, in the denominator, I have x minus 2 quantity to positive 3. So that's really the second derivative. So how do I find critical or possible inflection point? I was about to say critical values, but we're in the second derivative. I set this thing equal to 0. Obviously, at the top, I can't set equal to 0 because negative 10 can't be 0. But the bottom can be equal to 0, and that's where f prime does not exist, or f double prime does not exist. It's a potential inflection point. So I'm going to say, let's see what happens if I set the bottom to 0. So x minus 2 quantity to the power of 3 is equal to 0. Cube root both sides and add 2 to both sides, you get x is equal to 2. Notice that if this was squared, then even if it was squared, nothing would happen. Never mind, I thought we might have to do plus or minus. Ignore me. All right, so we have one possible inflection point, and we can already tell because it's an odd power. It is an inflection point. It is going to have a sign change. We just need to figure out where that sign is negative because that's the definition of concave down. Here we go. We're drawing our number line. On this number line represents x. I don't know if I did that for my other problems. I should be saying that these are all x, just to make it a little bit more formal. Those are all x, 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 good. All right. So now that I'm down here with where it's concave down, there's only one possible inflection point, and we already know it is an inflection point. I'm going to even label it since we know it's an odd power. Let's plug in a nice number into the second derivative. I love plugging in 0. When I plug in 0 into my second derivative right here, it's going to be 0 minus 2, which is negative 2. Negative 2 cubed is still a negative. Anything to an odd power is still negative. If it was a negative, and to an odd power it's negative, I should say it correctly. And then the bottom is negative, the top is negative. A negative divided by a negative is a positive. And therefore, it's going to switch over here and be a negative. I know it's going to switch because it's an odd power. Or I should say that is an odd power. From there, we're looking for its concave down, so anything bigger than 2. And the one thing that says that is E. X is bigger than 2. On to number 7. All right, we're looking for the point of inflection on this one. So give me the definition. What is an inflection point? What is the definition of an inflection point? It's where f double prime has a sign change. Very similar to the definition of a relative extrema, except it's f double prime instead of f prime. F prime sign change is a relative extrema. Notice that we're looking for the second derivative. We are given the first derivative, so we have to take the derivative twice and then see if there are any odd powers. All right, so here we go. Y prime, the first derivative, the 3 is going to multiply down in front, and then these 3's are going to cancel out. I'm going to be left with a coefficient of 2 out front. So it's going to be 2x to the power of, it used to be 3, it goes down to the power of 2, minus 2 times 2 is 4x to the power of, it used to be 2, now it's 1, and the derivative of a constant is 0. All right, that is the first derivative. Here comes the second derivative. I'm going to take the derivative of my first derivative. The 2 is going to come down in front, makes that a 4x to the power of, it used to be 2, now it's 1, minus, and then this is just going to be 4.
Okay, and I can definitely see how to factor this guy. If I factor this guy now, once I hit the thing that my definition is talking about, that's when you want to factor. So I'm going to factor out of 4. When I factor out of 4, I'm left with x minus 1. I have 4 times the quantity of x minus 1. Now I'm going to set that to 0 to find my possible inflection points. So I have 4 times the quantity of x minus 1. I'm going to set it equal to 0, and that means obviously 4 can't be 0, but x minus 1 could be 0, and that means that x is equal to 1. I know that this is an inflection point because this is to the power of 1. 1 is odd. Whenever you have an odd power, you're going to have a sign change, and that is the definition of an inflection point. So at x equals 1, correct answer is B. Number 8. Ooh, it's giving us the second derivative, and it's saying, where do I have inflection points? Again, you should know this. What is the definition of an inflection point? I'm going to write it every single time for every single problem. You should get in the habit of at least thinking this for every single problem. An inflection point is where you have f double prime sign change. So from here, we know we're already given f double prime. Sign change means I have an odd exponent. I'll write it down here as well because I'm using this over and over. Sign change, this right here means you have an odd power, or an odd exponent if you would prefer. All right, which of these have odd exponents? Well, that's even. This is odd, and this is odd because it's to the power of 1. Whenever it doesn't list it, it's to the power of 1. So the possible inflection point here and here are the actual inflection points because I have odd powers. So 0 and -1 are the only inflection points. -1 and 0, correct answer is C. All right, number 9. So we have the graph of f, just the normal f, no f prime, is given right here. Which of the following could be a graph of the derivative? All right, so usually you're talking about some sort of maximum or minimums or inflection points. Let's start with maximum minimums. So I have a minimum right here. I'll label it. This is a minimum. I have a maximum up here, and I have a minimum down here. The definition of a minimum is where f prime is changing from a negative to a positive. So that means at this x-coordinate on these graphs down here, I should have f prime change from a negative to a positive. But because these are graphs of f prime, what is f prime on a graph of f prime? It's height. So what I'm really saying down here is, where do I have a height change from negative to a positive? At this x-coordinate. So at that x-coordinate, it does change from a negative to a positive right here. So that one, I'll put a little check there. Let's check the other minimums. It doesn't change a height from a negative to a positive for B. It kind of looks like it does look like it for C. That's a negative to a, wait, I'm saying a negative to a positive. I am so sorry. Let's undo that. This went from a positive height to a negative height. That is the opposite of what I'm looking for. That was a maximum. So it's not A. I'm so sorry. Definitely not B. It doesn't even cross the x-axis. At C, it goes from a positive again to a negative height, which is a maximum. So it's not C. Wow, it's eliminating a lot of them. It's not D. It doesn't even touch the x-axis. Just with the first minimum alone, we have eliminated all choices except for E, which does indeed go from a negative height to a positive height. And we can check the rest of them just to be sure if you want, to make sure that we got it. We should also have a maximum at this x-coordinate, which means I go from f prime goes from a positive to a negative. And again, that means I have a height that goes from a positive to a negative. And look right here, I have a height that goes from a positive to a negative. And you can see over here we have a negative to a positive height, which is again a definition of minimum. It fits all of our minimum and maximum points. On to number 10. All right, so we have this function. It's defined between -2 and 2, not including the endpoints, so don't think about those. We're trying to find the following that describe the relative extrema of f and the inflection points on f. So I need to give both of those definitions. So what is an f relative extrema? You should be thinking about this before I write it down. A relative extrema is where f prime has a sign change. That's a bad I, sign change. And what is the definition of an inflection point? An inflection point is where you have f double prime having a sign change. Since I'm given a graph of f, so it says f is defined above, it's just normal f. On a graph of just f, and it even tells us up here, just f, what is f prime? F prime on a graph of f is slope. What is f double prime on a graph of f? That is concavity. So it's asking, where do you change slopes? So let's check it out. I have a negative slope, negative slope, negative slope. It goes to 0, but then it continues being negative slope, negative slope, negative slope until there's only one spot that you have a relative extrema, and it's right there. Then I change from a negative slope to a positive slope. So I have one relative extrema, and it's right here. This is the only relative extrema. Let's talk about the concavity change. This is concave up, and then it goes concave down, and then it goes back to being concave up. So how many times do I change? And it might go concave down later, but it stopped right there. I change between up and down right here. I don't know, somewhere. I'm just going to say like right there. And then it changed again. So I have those two, and they're very approximate, but I know that there's at least two, and those are called inflection points. So those are inflection point, inflection point. So now that we've marked up our graph using concavity and slope, let's come down here and read the answers. Is there anything that says 2 inflection points and 1 relative extremum? Oh, they're defining it even more so, minimum and maximum. Well, what type of relative extremum is this? This is a minimum because it comes down, that's the lowest point that you get. So there's only one minimum, so anything that says a maximum, you're definitely not correct. And there is a relative extrema, so it's not E. So there's one relative minimum. All A, B, and D say the same thing, and then you should have 2 points of inflection. This one has one maximum. I don't know what it's talking about there. Nope. 1 point of inflection, 2 points of inflection. It should have 2 points of inflection. On to number 11. So we have a y such that y prime and is greater than 0, y double prime is less than 0, and these are all the possible graphs of f. So y double prime is greater than 0. On the graph of y, what is y prime? Is it height, slope, or concavity? If you said slope, you would be correct. What about y double prime? On the graph of y, what is y double prime? Y double prime is concavity. That means the slope is positive, it's concave down. So for all values of x, so every single thing needs to have a positive slope. A, everything has a positive slope. B, everything has a positive slope. Nope. C, you have negative slopes. D, you have a negative slope down over here, so no, not you. And E, you are all positive slopes. So check this one off. Yep, we checked all the positive slopes. So it's between A, B, and E. Now it should be concave down for everything. A is concave up, so it's definitely not A. I can leave the arrow on here for the notes as well. B is concave down, so far so good. And E is concave down over here, but it's concave up over here, and it needs to only be concave down, so it's not E, it is only B. Number 12. So twice differentiable, that just means we're allowed to take the derivative twice. And we know that G prime is greater than 0, G double prime is greater than 0, and it also gives us some numbers. All right, so this is saying that the, what's a good way to think of this problem? I'm thinking this is kind of like a table problem since they give us only certain values. What is a possible value for g of 6? Yeah, so I'm thinking this is kind of like a table problem. While yes, you might think of, okay, this is slope or this is the derivative, the best way to think about this for this problem is that this is the first difference. And I know I haven't really gone into depth on this, and it's just one of those things you have to kind of learn on your own. This is one of the hard problems, I guess, because I haven't taught it explicitly, and this is the second difference. And if you're confused right now, you're like, what do you mean first difference or second difference? Once you look at a table, it becomes very clear. So let's look at our values of x, our values of y, our first, that is a poor eye, Mr. Sindel, first difference, and our second difference. Probably didn't need that much space, but whatever. Okay, so I have the x coordinate of 4. Whatever's inside here is the x coordinate. It goes 4, then 5, and then it's looking for 6. So 4, 5, and 6. The y is this number. So 4 corresponds to 12. 18 corresponds to 5. And we don't know what this value is. We're trying to figure out these are the possible numbers that I can be putting in this spot right here. I don't know what it is. So I know that the first difference has to be positive. That means if I do 18 minus 12, I should be getting something positive, and indeed I do. I get a positive 6. So 18 minus 12 is 6, which means this number, whatever it is, I'm going to leave it as my box because that's what I'm trying to figure out. This number minus 18 has to be some sort of positive number. I'm going to erase this because I'm going to have to change it in a sec, but it needs to be something positive or bigger than 18. Well, that obviously eliminates 15. And it obviously eliminates 18 as well because 0 is not positive. It didn't say greater than or equal to, it said greater than 0. All right, so it's between C, D, and E. We also note that the second difference is also positive, which means the first difference, if I compare that to the next first difference, this, I'm going to do like a cloud box. This cloud box minus 6 has to be some sort of positive. All right, let's just plug in a number and see if it works, right? If I do 21, 21 minus 18 is 3. So far, so good. 3 is a positive number. It satisfies the first difference. But 3 minus 6 is a negative. It's a negative 3. That does not work. So you can probably see the pattern already. If I plug in 24, it's still not going to have a big enough first difference in order to be bigger than 6. If I plug in 27, however, I'm going to do this in a different color. If I plug in 27, 27 minus 18 is, I'm blanking right now. It's 9, isn't it? 9. 24 minus 18 is 6. 6 and 6. Yeah, that would be 0. You need a positive. Yeah, 27 minus 18 is 9. 9 minus 6 is indeed a positive. In fact, that is the only number that has a second difference that is indeed bigger. So the correct answer here is E. On to number 13. So we have the graph of f prime, the derivative, shown above. So this is a graph of f prime. Which of the following describe the relative extrema? So let's just go ahead and not even look at the multiple choice answers and just analyze this graph. So the definition, well, they're talking about maximum and minimum, obviously. So let's define only those two. What is a relative max? So I can say relative max, or I'm just going to say f max. I'm going to be lazy. What is a maximum and what is a minimum? The maximum is where f prime goes from a positive to a negative. And then minimum is where f prime goes from a negative to a positive. So on a graph of f prime, though, what is f prime? These two both match up. On a graph of f prime is height. So I'm really asking questions about the height here. So where do I have a height that goes from a positive to a negative? Where do I have a height that goes from a negative to a positive? So let's go ahead and analyze our graph some more. Our height goes from a negative to a positive, so this is a minimum. Our height goes from a positive to a negative on the second point, so that is a maximum. And our height goes from a negative to a positive over here, so that is a minimum. Okay, now let's find a multiple choice answer that has two minimums and one maximum. And it always starts with maximum first. So one max, so it's between A and D just from the get-go, and 2 minimum. And there it is. A says 2 minimum. Number 14. This is a review question. So, which about the following statements is false? So you have to, it's like a double undo for some of these. So we're looking for something that is false. That means most of these are going to be true. F of x is continuous at x equals 2. So at x equals 2, again, the informal definition is continuous means I don't have to pick up my pencil. If I'm discontinuous, I have to pick up my pencil somehow. So do I have to pick up my pencil? No, I don't have to pick up my pencil. I hold it down and it's fine. So that is a true statement. So that's not the answer. I'm looking for something that's false. All right. The limit of f of x as x approaches 2 from both sides, because there's no plus or minus, you always assume both sides, is some height. What height when I approach 2? When I approach this x value of 2 from the left and from the right, what height do I go to? Well, I approach the same height, 2. So we know that this value is 2. 3 only from the positive side. So when I approach 3 only from the right-hand side, not the left-hand side, what height do I go to? I approach 2. So does 2 equals 2? It does indeed. This is true. So that's not the answer because I'm looking for something that's false. F of 3. F of 3 is the height at 3. What is the height at 3? And again, you kind of draw a wall through 3, and you see, where do you intersect? I don't intersect through here because that's an open circle. I do intersect here because that's a closed circle, I should say, closed point. So the height for here is just 1. So it's saying f of 3 is not defined. is defined, so this is actually the false statement right here. F of 3 is defined, and it is defined to be 1. So C is the answer, f of 3 is defined, and f of 3 is equal to 1. Let's talk about why these other ones are true. F of x is not differentiable at x equals 2. Okay, so what are things that will make you not differentiable? Can you list them? I'll list them up here. Not differentiable. There are only 3 things that you need to know. I'll do 1, and then I'll have A, B, and C, 2, and 3. What are the 3 things that will make it not differentiable? Well, the first thing is not being continuous. Not continuous. And I should have a D right here because I realize there's 4 things that will make you not continuous. What are the 4 things that will make you not continuous? Holes, gaps, vertical asymptotes, so VAs, and endpoints. So that was the first thing that will make you not differentiable. What's the second thing? The second thing are sharp corners. I cannot spell sharp corners. And then the third thing that will make you not differentiable is a vertical tangent. So, do I see any of these 3 things at 2? Well, at 2 I have a sharp corner. If I have a sharp corner, then it's not differentiable. F of x is not differentiable. Well, that's a true statement because I have a sharp corner. So this is kind of like one of those double negatives. So it's not D, and f prime of 3 does not exist. The derivative at 3 does not exist. Well, if I'm again checking the definition of is it differentiable. Am I differentiable right here at 3? No, I have a giant gap. I have this definition. I have a gap. Look, it jumps from here to here. There's this giant gap in between, so it's not differentiable, which means I can't take the derivative, which means when I look for the derivative, there's no derivative. It does not exist. This is true. The derivative doesn't exist because it's not differentiable. So the correct answer is C. Number 15. So we're continuous and we're on the closed interval. So which theorems have we unlocked just by saying continuous and closed? Continuous automatically unlocks IVT. Closed, and if you're continuous and closed, you have to have both of them, then you've unlocked EVT, extreme value theorem and intermediate value theorem. Which of the following must be true? And again, what do they say? IVT says stuff about heights. EVT talks about mins and maxes. Min and max. So you can kind of ignore everything from here onto the left. I know that one of them, it's a closed interval and not an open interval, so maybe it's wrong. They aren't going to do that to you on the AP test. They're basically, all of this stuff is saying essentially the same garbage. Let's look over here purely on the right-hand side. Pay your attention over here. So f of c. What type of thing am I talking about? Am I talking about mins, maximums, heights? Am I talking about slope? It's only one of those things, by the way. It's talking about heights here. It's saying that the height is 0. Well, this would be true, and okay, I should analyze this a little bit more. Which the following must be true. That means the majority of these are going to be false. All but one of them is going to be false. So A is false. Why? Because they don't give you enough information. Like if it said, oh yeah, I passed through -1 here and +2 is here. Oh yeah, you have to go and have a height of 0 somewhere. Well, they never even told us that we had a height that was above and below 0, so we don't know that you hit a value of 0 for a height. All right. What about B? So let's cross off A. What about B? So for some f of c, I have to be between A and B. The problem with this one, if you remember, is that there's no equal to sign here. If there was an equal to sign, yes, you could say B, because that is almost the definition of intermediate value theorem. Like if you have a height that's low and a height that's high, then there should be some height in between as long as you're continuous. The problem with that is a constant function. A constant function between here and here, it's saying, oh, it can't be strictly equal to. You're not allowed to have an equal to sign for the height, but all the heights are equal to, yet you're still continuous, so this breaks B. All right, and I have explained that more in a video before. That's kind of why I'm giving a lackluster explanation right now. There is a number such that, okay, so this, what is the definition? You should know the 3-letter word that this represents. This is a maximum. Is there a theorem that guarantees a maximum? There is indeed. This is guaranteed. So I should go back here. This is guaranteed true by EVT. This is the true theorem. The correct answer is C. It says that there is a max. It's pretty generic. It doesn't say where it happens. It just says, yes, there is a max, and that's what this is saying. Let's talk about why D and E are both false. D is false because it's talking about the derivative. You cannot say anything about the derivative because you haven't unlocked mean value theorem. You have not said it's differentiable. Also, even if you unlocked it, they didn't even give you any numbers, so if it gives you a number over here without giving you any numbers up here, you know it is wrong. E. This is the definition of mean value theorem. This is like the exact definition of mean value theorem. If I somehow said differentiable up here in the question, then this would have been true, but it didn't. So I can't even use mean value theorem. So this one is false, and this one is false. And crossing off E. Number 16. All right, the slope of the line tangent to this graph. Okay, so if I'm looking for slope and it just says slope, slope is the derivative. So I'm looking for the derivative and I'm plugging in e squared, whatever the derivative is. So first take the derivative, then plug in e to the power of 2. And you have probably seen this problem before. I haven't even mixed up the multiple choice answers. It's a hint, it might be in the future too. I kind of recycle questions. Here we go. If I take the derivative of this, y prime should be equal to, well, log house, the derivative of log house is 1 over the inner. So 1 over, where's our inner? Our inner is x squared, so 1 over x squared. But that is only doubter. What about dinner? Dinner, the inner here is x squared. So dinner is the derivative of x squared, which is 2x. When I simplify this, I get 2x over x squared, and I can cross off one of the x's on the bottom, one on the top, and I get 2 over x. I have now taken the derivative, and I said I was going to plug in e squared into the derivative. When I plug in e squared, this x changes to an e squared, and I get the final answer of 2 over e squared. Where are you? There you are. B, correct answer. Number 17. Again, this problem looks very familiar. We did it last time. I have this as a function, and I need to take its derivative. The problem with taking the derivative is you have this ugly, gross fraction. So, just as a note, 1 over x can be rewritten. I'm just talking about this power right here. 1 over x can be rewritten as x to the power of -1. It makes your life so much easier because there are no fractions. So that means I can think of this whole function, then, I'm running out of room, I'm going to do it up here. E to the power of 1 over x can be rewritten as e to the power of x to the power of -1. There's like a chain of powers here. So I need to take the derivative. First of all, what is the house that I'm in? My house is e house. So the derivative of e house, the doubter of e house, is e to the x to the -1. It's the same. In fact, I can just rewrite this as, I'll leave it as e to the 1 over x. I don't need to change it quite yet here. However, I do now need to multiply by dinner, the derivative of the inner. The inner is 1 over x, and I don't like taking the derivative of a fraction. So I'm going to take the derivative of x to the -1. When I take that derivative, I'm finding dinner, the derivative of the inner. So when I take the derivative, the -1 comes down in front, and I have negative x. It was to the power of -1, but now it's to the power of -2. There it is, doubter times dinner. I just need to simplify it now. When I simplify this, in the numerator, I'm still left with e to the 1 over x. And now the denominator, I have, let's get rid of this negative. This negative we'll put out front. There it is. Now in the denominator, I have x to the power of +2 because it's going down. So x to the power of 2. Where is that answer? It looks like the answer is A. Number 18. Again, a very similar problem. And you're thinking, oh, like the pretest was 12, the test was 15, it's probably one of these two, and I think you're right. So this is just testing you on what is the derivative. The derivative, if I have an outer, and I should write this out too, this is the outer, and then g is the inner. The definition of the derivative, well, I don't know, the definition of derivative is like very specific, it's like with h's and stuff, but the derivative is literally just doubter times dinner. Doubter, and I'll even write it down, I think that's important. Doubter, the derivative of the outer times the derivative of the inner. That's chain rule here. So what is the derivative of the outer? Well, outer is f, so the derivative of the outer is f prime. And then leave the inner for now. So the inner is still g of x. I'm now going to multiply this by dinner. Dinner, well, the inner is g, so the dinner is g prime. There it is. So, and I'm not writing very neatly, I want to redo that. G prime of x, it looks a little bit better. Now it's saying plug in 1 to that. So I'm going to have here g of 1. This is g of 1. This is g prime of 1. And I'm going to do f prime of whatever that is. I'm kind of working up instead of down. So what is g of 1? Let's look over here. G of 1 is 3, which means this is now 3 instead of g of 1, and I still have this f prime on the outside, times, well, what's g prime of 1? G prime of 1 here, g prime of 1 is negative 3, so this is times negative 3. All right, now I need to simplify. What is f prime of 3? Where is f prime of 3? F prime of 3 is negative 5. So this is now going to turn into, I'm running out of room, negative 5 times negative 3, which is positive 15. Correct answer is B. And I went from here to here to here, just showing my work, and then from here to here. Arrows do help me when I'm trying to look at your work. Second to last question, number 19. Piecewise function. And it's differentiable. So whenever you see piecewise and it's differentiable, that means you're going to be taking the derivative. Alright, so we might as well just get it done with, right? Let's take the derivative. F prime of x. When I take the derivative of a piecewise function, you take the derivative of the top, place it here. Take the derivative of the bottom, place it here. Here we go. Derivative of the top. Derivative of e to the negative x, and then, well, a constant is 0, so ignore the plus 2. Derivative of e house is just e house. E to the negative x, just copy it down. But that's just doubter. I need to multiply by dinner. Dinner, well, let's look at this. This is inner. Inner is negative x, so when I take the derivative of that, I get negative 1. So if I'm really simplifying this, I could come back here and say, oh, that's times negative 1, so just negative e to the negative x. There it is. What about this bottom part? Again, b is just some number, so it's a constant. Derivative of a constant is 0. Ignore it. Ax, though, when I take the derivative of that, that's the equivalent of like 3x or something, because a is just a number. When I take the derivative of 3x, I get 3. So when I take the derivative of ax, I get a. Cool, so there it is, and you can say, oh yeah, if you want to be correct, it's for x is less than 0, for x is greater than or equal to 0. It doesn't matter for us. So from here, we're going to set the left piece equal to the right piece and plug in our suspect point. So right now we're just working with a continuity test. So the continuity test tells us that you just set the left equal to the right for the regular non-derivative for just f. So e to the negative, it used to be x, but now it's 0 because I'm plugging in x is equal to 0. Plus 2 needs to be set equal to, the left piece equals the right piece. The right piece is over here. It's going to be a times, well, x is 0 plus b. And let's see how much we can solve. E to the 0, anything to the 0, and this is negative 0, which is the same thing as 0. Anything to the 0 is just 1 plus 2 is equal to b, because a times 0 is 0. That means b is equal to 3. Cool. Well, we've got half of it. We know that this b is 3. We need to find a now. So to find a, that's how you're going to find a. You're going to set a equal to this negative e to the negative x. So here I go. A, well, I should do the left piece equal to the right piece, just to be consistent. This is the differentiability test. Diff test. The differentiability test says the same thing, just with the derivative now. Set the left equal to the right, plug in the suspect point. So negative e to the negative 0, because I'm plugging in the suspect point yet again, is equal to, and I can't plug in anything, so I'm just a. There's no x to plug into. You can only plug in for x, not other random variables. Well, again, anything to the power of 0 is 1, but now it's a negative 1, so I have negative 1 is equal to a. Again, I just need to add a and b. Negative 1 plus 3 is 2. All right, our final question for pretest number 3. Here we go. We have a function. This is f up here, so we can label it, this is just f. And you can take the derivative twice. Which of the following is true? And it's talking about the height, the slope, and the concavity. So I will write this out to the side, but this is saying that f is just height. F is height. F prime is slope. F double prime is concavity. And this all assumes that you're talking about a graph of f. On a graph of f, f is height. On a graph of f, f prime is slope. On a graph of f, f double prime is concavity. All right, let's just go ahead and analyze the graph. Ignore all of this for now. So at the point 1, all of these have 1 on them. So at this point, ignore everything else. At this point, what is the height? Well, the height here is 0. What is the slope? The slope is some positive number. So the slope is, I'm just going to put a positive. And the concavity, it's all concave down at 1, so this is a negative. All right, well, order them from least to greatest, because you say this one is less than this one, which is less than this one. Go from least to greatest, so I should have negative, then 0, then positive. So f double prime, f, then f prime. F double prime, f, then f prime. Correct answer here is D. And that concludes Calculus Pretest number 3. Thank you for watching. If you have any questions or if there are any corrections that need to be made, please let me know.